Welcome to my talk. The title of this talk is Taming the Beast, and we're going to talk about monitoring your CI/CD pipelines and using data to improve them. So, quick agenda. I'm going to do a short introduction, and then I'm going to talk about a job monitoring plugin that I built, give a quick demo, and then I'm going to share some of the dashboards you can build, and I'll close by talking about how we do DevOps on my team at GoDaddy. So, a little bit about me. I've been at GoDaddy for about 2.5 years. I manage a small team of engineers. My office is in Kirkland, Washington, which is located just outside of Seattle. Before that, I was at Microsoft for 24 years, working on a variety of products, so I've done quite a few things there. And before that, back at the dawn of computing, I worked at General Motors doing mainframe stuff. I'm involved in the Jenkins community. I'm one of the maintainers of the Kobatura plugin, have a job and stage monitoring plugin, which we'll talk about during this presentation, and then a new plugin that I hope to get released in the next week or two. It's called Working Hours, and it lets you set a schedule and have jobs that run outside of business hours queue rather than deploying. Another thing, I'm a certified Jenkins engineer. I took the test last year at Jenkins World and got certified. And this summer, I had a great opportunity to work with the Jenkins project with the Google Summer of Code. We had several interns that were working on various projects, and I helped mentor an intern that was working on some code coverage improvements. So I wanted a little bit about GoDaddy. Most people probably know that GoDaddy is the largest domain registrar, but you may not know that we also have a passion for helping small businesses. And I included this slide because this is something that my team is directly involved in, and it's something that I really believe in, so I wanted to talk about it. Our headquarters are in Scottsdale, and we have offices around the world. So this is a slide about the team that I work on directly. It's called Go Experiences. And the main thing that we provide is a framework which provides personalized insights and suggestions to customers. So we have a back end that uses personalization to give suggestions and keep track of which things customers act on. And then we have some applications that our customers can use to see the suggestions. We have around 50 engineers. So we have an office here in San Francisco. We have a Sunnyvale office. Of course, we have the Kirkland office, and we have people in Arizona and also remote. And just a quick little bit about some of the technology we use. JavaScript, React Native, Swift Java, and Python on the back end. So just real quick, I want to talk about how we do DevOps, because it's going to figure into some of the later slides. So we're very lean. We don't actually have a DevOps team. We like to say that the entire team owns the Jenkins cluster and all of the pipelines. Everybody's expected to be able to diagnose and fix issues, but in practice, there's people like me that have been interested in learning about Jenkins, and so we tend to help out and pitch in when there's difficult problems. Works pretty well for us most of the time, allows us to move fast. No system's perfect, but this is what we like to do. And just a quick thing, just to give you an idea of the scope. We have, again, 50 engineers. We have one Jenkins master, about 20-ish Jenkins agents that are hosted on OpenStack, handful of iOS agents. So medium-sized Jenkins cluster, nothing big by any means, but this is what we have. Okay, so in this section, I'm going to talk about some of our early attempts at monitoring, and then I'm going to move into some of the challenges that we were facing in our main client-facing application. So this is the case study. I'm going to talk about our client app. This is the customer venture client. It's a showcase for our personalization engine. It's written in JavaScript, and it uses React to render the web and React Native to render the mobile. So here's an example of a web application and iOS application side by side, showing the same sorts of customer feedback. So yeah. So all of this is built in one pipeline. 85% of the code is JavaScript that is shared. Again, React for the web, React Native for the mobile, and then there's just some glue pieces that use Swift for iOS and Java for Android. And it's what it looks like in Jenkins. So we build a bunch of stuff in parallel. We build Android, iOS, web. If everything looks good, we deploy just the web part. So every change that's merged automatically goes into the customer's hands as soon as we can get it merged and verified. Okay, so this is our first attempt at monitoring. We did this at the very beginning of the project, actually before I started. So the idea here is that we put some build lights in the Kirkland office. We put Philips Hue bulbs in them, and we set it up so that if the last master build passed, it's green. If not, it's red. Somebody needs to take a look at it. Works pretty good, but obviously there's a geography problem because the build lights are all in the Kirkland office, but our folks can be working anywhere, so it doesn't work for everybody. Kind of another way of putting this, Washington State, build lights are great, otherwise not so much. So we still use them, they're still important, but we also have other ways of getting immediate monitoring. So this is an example of our on-call channel for Slack. So we have one channel that gets all of the things that we expect an on-call engineer to pay attention to. So up at the top, you see some warnings about a service that maybe is slow, and then it gets cleared. And then there's a failure in one of our jobs, and so that's something that we expect the on-call engineer to handle as well. So this raises some problems. All the monitoring solutions that I talked about so far rely on just looking at the last job. Now, Jenkins has some historical information, but we keep, I think, 20 builds, so we don't have a lot of information, and that's probably just a couple of days worth. So recently, we started hearing this comment: the build seems like it's always broken. People were very, very unhappy. Developers were unhappy because they had nothing to do. You know, these guys look happy, but trust me, they weren't. And, the product owners were unhappy because they weren't getting new features. Nothing's getting done because we use CI/CD to deploy everything, and nothing was working. And the dev managers they're just unhappy. So one of the things that we like to say, and a lot of people say this, but it's true in our org, we're a data-driven org. We measure everything. So here's some of the things that we measure. When we're making content changes, we use A/B testing to measure how interesting it is to the customers. If we publish new content and it doesn't seem interesting, then we'll probably remove it. We use New Relic to monitor the success rate of all of our services. So we have dashboards that tell us exactly how we're doing in terms of response rate and whether we're returning any warnings or errors. We use a service called Track.js to monitor JavaScript errors, and something called Fabric to get mobile errors, and we keep track of things in Kibana and Elasticsearch, and we also use something called User Voice to collect qualitative data directly from our users. We also even know the page load time for all of our apps from various locations around the world. This is something that's built into the JavaScript framework, and so every web property at GoDaddy has access to this, and it's great information. So, given all that, it seems like if we can collect this information about customer-facing services, maybe we could do the same thing about our CI/CD jobs, hopefully without having to make a bunch of changes to all of our Jenkins files, because that's just extra work. All right, so now I'm going to talk a little bit about the solution that we came up with for addressing our CI/CD problems. So this is the GitHub Auto Status plugin. It's something I wrote maybe a year ago. I was converting a bunch of jobs to declarative pipeline, and a lot of our jobs tend to want to have this sort of granular status on the pull request page, and we had a shared Groovy library which enabled this, but when I started converting the jobs, it seemed like it didn't really translate well to declarative, so I created this plugin, and we removed all of the stuff from our jobs that was doing this. And here's an overview of how it works. So Jenkins has a graph listener extension point. Any plugin can implement this, and if you do this, then you get notifications of build nodes, and All the plugin really has to do is look at the build nodes and see if they represent stages. If so, then at the beginning, they can send stage pending for everything, and then at the end, they send either success or error. So when I started thinking about our problem, it seemed like this plugin kind of did what we needed. Not quite, but it was a step in the right direction. So I created a list of things that I would need to do if I wanted to use it to create dashboards. So here's some of the work I identified. The original plugin only supported declarative pipelines because that's the problem I was trying to solve. It turns out that supporting scripted is a little bit more difficult because it's a little bit more freeform, but it's not impossible. And then also there's just some refactoring that needed to be done in order to send information to something that could build dashboards as well as GitHub. And so anyway, this amount of work didn't seem insurmountable, so it took a month, and then we had this new plugin. And so this looks a lot like the old one. All of the green text stuff that was added. So as you can see on the left, we have the graph listener extension point, added a run listener extension point, which gets information about overall jobs. And then over on the right, you can see it sending additional information, timing information and job success error. And in addition to sending it to GitHub, it can also send it to an InfluxDB installation, which allows you to build dashboards in Grafana. So voila, we have lots and lots of charts. All right, so now I'm going to look about a couple of the things that we were able to do to improve our builds using these charts. And then I'll talk in general about some of the other charts that you can produce with the plugin. So again, this is the Ventures home client that I was talking about earlier. If you recall, we were at a point where it just seemed like the master build never succeeded and everybody was unhappy, but we weren't sure which parts needed the most help. So I'm going to show a couple of the things that we were able to do to improve the pipeline. So the first thing, we noticed that we were getting a lot of iOS failures, and it was a little bit puzzling, actually. It seemed like from time to time, a whole bunch of jobs would just fail. They were unable to clone the Git repo for whatever reason. And so this little chart on the left is just a raw count of failures per stage over some time period. I guess this was about a month, and I collected the ones that were failing the most, and so the iOS was the highest, Web UI test was second, but we chose to attack the iOS first. So it turned out that the problem was partly geography, but mostly SLAs. So our iOS agents were actually up in our Kirkland office, and we have a rented office building that doesn't necessarily have great network capability. Our Jenkins master and our GitHub Enterprise are down in Arizona in a customer-facing data center. Obviously, those have great SLAs and great network latency. And so just every now and then, things just wouldn't work, and our iOS agents were not able to talk to either or our Jenkins master or GitHub. Solution was actually pretty simple. We just moved the Mac Minis down to Arizona, and the problem went away. So this chart kind of helps demonstrate a little project that we did to improve build times. On the left, you see average build time, and down at the bottom is just date. So one of the things that our mobile team wanted to do was investigate switching the JavaScript driver that they were using to run the test. Before, they were using something called WD, and there's also something called WebDriver IO. So they made the switch, and they measured the effect on the build, and it turned out that it actually improved the build times, and it improved build quality as well. So in this case, just that one change made an improvement by about 5 to 10 minutes. That's not bad. We were at about 30 minutes. And down at the bottom, there's a link to a blog post where one of our engineers that does a lot of mobile stuff talks about how they do testing and kind of compares these two solutions. So the last thing, not too long ago, we had a couple of back-end outages that affected our CI/CD pipeline. The first problem was SSO related, and so the tests weren't able to sign in, and that was causing them to fail. That was actually a customer-facing issue, so that got fixed almost immediately. But about the same time, the backend had an issue that was causing it to return 500s, but only for test data. Since this one didn't affect customers, it didn't fire alerts on our dashboards, and so it took us a little bit longer to figure out what it is, but eventually we found some out-of-memory issues on the back end, and as soon as we fixed those, you can see the success rate going back up. So this kind of shows the value of looking at historical data. You could sort of suss out whether your builds are getting better or worse with this kind of a chart. All right, so how are we doing? I'll give you a couple of examples. So if we look at just the success rate of this one build, back in February, we were at about 34%. This was before we started moving our iOS slaves around. And now we're at about 83, 84%. Not bad. I'd like it to be above 90%, but it's definitely a step in the right direction. We're still dealing with iOS agents. They're a little bit tricky. Apple makes it's not exactly an open development environment, and things change relatively rapidly, so it's just something that we continually struggle with, but still 83% isn't bad. So if we look at the build times, the story is a little bit mixed, actually. If I show these two charts, we were at about 34 minutes back in February, and last week we were averaging about 27 minutes. If I showed you a chart over time, you'd actually see that it kind of goes up and down and hovers around 30 minutes. What tends to happen is we make some small improvement, it goes down, then we add some tests and it goes back up. But for me, anything in the 15 to 30 minute range for a master build, which includes deploying to AWS, is pretty good, so I'm pretty happy with this. Okay, so a little bit of work left to do on the monitoring plugin. So one of the things I'd like to do is start measuring test case pass rate. One of the big problems in CI/CD pipelines is having flaky tests that pass most of the time, but occasionally will fail. I'm sure you've encountered this. If you have more than one of these tests, chances are that overall they add up to a pretty flaky pipeline. So the second thing, I want to ensure that we don't lose momentum or regress in any way. When this all started, obviously, we were looking at these charts all the time and trying to figure out what was going on. Now that things are relatively good, it's tempting to not look at the charts regularly, but by doing that, then we risk regressing. Going to add some additional dashboard types. There's other teams at GoDaddy that would like to use this, but they prefer using Kibana for their monitoring, so I'm going to probably support Elasticsearch relatively soon. It's pretty easy the way the plugin is currently refactored. And then possibly adding some other monitoring types. We have steps that do Slack or email. I think that I could probably leverage existing plugins and wrap them with my plugin, and then get rid of some steps in our Jenkins files and simplify things. Okay, so let's take a look at some of the things that you can measure. So the current plugin, you can measure the job success rate, overall job build time, success rate of individual stages, and the overall stage build time. So here's an example of a chart. It just shows the success rate over some period of time for several services. So in this case, it's over the last 90 days. So with the coloring, it seems pretty obvious that the two in the middle are green. They're not too bad, but the two yellow ones are probably things that we should be looking at sometime pretty soon. So it's just good at getting an overall idea of how all your builds are doing. This is something that we look at pretty regularly. Okay, this type of chart just shows a raw count of stage errors, again, over some period of time. It's just useful to help drill in. If you're having problems with your build, you can see which stages are failing the most often and look at those first. And this chart I showed you earlier, it's a daily success rate over time, so it's just useful for identifying trends. It helps you understand whether you're getting better or worse, which is always good to know. And this chart shows average daily build time, and again, it's useful for looking at trends over time. As you can see, I think I mentioned we've hovered at just under 30 minutes for a long time, and so that's where we're at. That's not too bad. So this chart's similar, but it shows build times for individual stages. So you can use this to fine-tune your pipelines by looking at how long it takes for each stage to build. Okay, so This is one of my favorite graphs. This is something that I just created. So we have a couple of jobs that just seem like they never complete. We have a lot of teams sharing our Jenkins, and so these are jobs that aren't part of the core areas, and they don't get a lot of attention, but you have something that's running 4 days, and it's taking up a build agent for that entire time. And also, occasionally, we need to restart Jenkins, and these jobs get in the way. So I created a special report, hoping that when I start publishing this, I can do a little bit of social engineering to kind of coerce the owners into looking into the pipelines. So similar build of shame. This one is pass rate. We have a couple of jobs that never seem to pass. And so this report just shows some jobs that somebody needs to look at because they have either a very low or in some cases 0 pass rate. So you kind of wonder what they're doing in the first place. All right, so for the next part, I recorded some videos in the way of demo to kind of show how to set this up. This is all using, I have Jenkins, InfluxDB, and Grafana set up in Docker containers. I'm not going to show how to set that up, but there's some slides later in the deck that show that, and I'll skip through them, but if you download the slides later, then you could use that to set it up if you want to play with the stuff. Okay, so the first demo, I'm going to show how to install and configure the monitoring plugin. So the first thing you have to do is install the plugin. If you're a Jenkins admin, you've probably done this hundreds of times. You just go to the Available tab. You have to find the plugin, Job and Stage Monitoring plugin, click it, and then click Install. Since it's a new plugin, then you can do install without restart, and everything's just fine. Next, you want to go into Configure System and find the Auto Status section. So as you can see, it's sending to GitHub. Also click Send InfluxDB. And then go up, and we need to give it the URL of the REST API and the database that we want it to write to. And that's all the configuration that's required. All right, so finally, we go to the Influx CLI. They don't really have a great UI, but they do have a CLI. You just need to go in and create the database that we configured in Jenkins so that it has someplace to write the data. All right. All right, so the next demo is just going to show how you can make sure that the data is actually getting to InfluxDB. So I have a couple of jobs here. They're just real simple Groovy scripts that are configured to fail at different rates so we can get some kind of different stats to build a dashboard around. So I'll start this demo. Take a quick look at the job. You can see it's got a few stages, and it has a randomly should I fail step. So we'll kick off each of these jobs once, 2, 3. And then we'll jump back to the InfluxDB CLI, and we'll just check and make sure that we have data flowing. So we have job stats, and we have some stage stats. Yes? So that all looks good. Okay, finally, I'm going to show how to configure Grafana and create a simple dashboard. So in this video, there's a part that goes kind of fast that I don't really have time to talk through, but it uses something called a Grafana template variable, and all that is a simple query that allows you to use one dashboard and reuse it for different repos. So when you see that, that's what that is. Okay, so the first thing you need to do is configure the data source. You only need to do this once, so we'll call it JenkinsDB. It's an InfluxDB data source. Give it the same REST API that we gave Jenkins. And tell it what database the data is in. So we save that. And next, we're going to configure the template variable. So this is just a query that says I want to be able to build a dashboard for all of the repos that I have data about. So we call it repo, give it the name of the database, give it a query. There's the preview of the values. That all looks good. And then we go to the dashboard. And we're going to create a single stat. It's just kind of the big number that tells you how you're doing. So for the title, we're going to use that template variable so that it gets expanded for the chart. As you can see, it's expanding it as you type. Go into metrics to create our query. So we want to look at the job metrics. We want to look at metrics that match the repo of the template variable. And we're going to look at average job time. Finally, we configured the display a little bit. The number ranges from 0 to 1. It's a percent. We want it to display as a percentage, so we configure that. All right. And then finally, I'm going to set up some thresholds so that we can color the background depending on how good or bad the build is. All right, that one's 100%, so it's green. The middle one's going to be yellow, and the bad one's going to be red. So that's kind of a quick way to set it up. Now, one of the nice things that I like about Grafana is they have a community where you can upload dashboards. And I've uploaded a couple of dashboards that do things a little bit more sophisticated than this. And as I get requests, I could probably add additional ones. So that's a way to get jump-started if you're interested in doing this stuff. So again, I said I had some slides that just talk about my demo prep. So I'm not going to go through these, but here's the Docker command to run Jenkins, InfluxDB, and Grafana. Those are the three pieces. All right, the next section, I want to talk about some of our CI/CD practices a little bit. I'm going to shift gears a little bit. One of the reasons I wanted to include this is, as I mentioned, I've been in the industry for a long time. I still love my job, but this is the first company I've been at where I feel like the group I'm in does CI/CD really well. All of our entire project has been full CI/CD where every PR gets merged to master from the beginning. We had great buy-in from our manager, and people figured out how to get it done. And we don't do any new projects without setting up the pipeline from the very beginning. So here's one thing. You want to build as much in parallel as possible. So this is important because it speeds up your builds. Your developers get feedback more quickly. If there's problems, they can fix them more quickly, and they just get work done. Speeds up deployments, so you can get your fixes and changes out to customers more often. And so there's just a kind of a quick pipeline. This isn't the client that I was showing you. This is one of our back-end ones, but you can just see we have lots of parallelism. And this is what it looks like in practice. This is kind of a typical parallel pipeline. So got a few steps, run things in parallel. If you know Declarative, then this is pretty simple. Okay, so another thing that we do is we pay attention to unit test coverage. So why is this important? Well, first of all, let's talk about why it's not important. So we don't do this so that we could directly measure quality. If somebody were to come up to me and say, I have 100% unit test coverage, so I have no bugs, I wouldn't buy it. I don't think you would either. So that's not the reason that we do it. So here's some of the reasons that we do like to measure unit test coverage. So this is the biggest thing for me, and I've seen this on my team. It helps build a culture where team members just pay attention to test coverage and hold each other accountable for providing the right amount of tests during pull requests. And one of the things that I stress with my team, if there's a bad deployment because somebody missed a test, it's not just the dev that made the pull request that's to blame. The people that reviewed the pull request also share in some of the blame. But above all, it's a failure in the process. We just need to get better at pointing those things out before they happen. And then so I find that when I'm paying a lot of attention to unit tests, I find a lot of missing test cases. And we don't have any problems where there's completely new features that have poor or worse no test coverage. And it's kind of a little thing from TDD, but I do believe that when you pay attention to tests while you're early in the process of writing your code, it helps with the design. It encourages encapsulation. It forces you to think about how you're going to expose your units to other components, and it's just a good thing. And finally, it's a little bit of a cop-out, but it's probably good to know where you are, even if you don't have a number in mind. You can always strive to improve. So here's some of the ways we put this into practice. We use GitHub templates for pull requests. And so if you haven't used GitHub templates before, what they do is they provide kind of a checklist as reminders to your engineers when they're making pull requests. And so here's an example of one. NPM test, that's the existing test. So we're asking the engineer to say that they ran the test locally. And the second test, we're asking them to say that they've included tests as appropriate. And here's an example. So I said a culture of accountability. And so here's an example of a lazy developer, happened to be me in this case, trying to merge a PR and not providing tests. And so one of the engineers on my team called me on it. And so I wrote the test and asked for review again and merged the PR. And here's an example of looking at running tests in the console for a Node.js application. So you get some pretty good information about coverage. The top's cut off, so you can't really see the different columns, but it's line coverage, branch coverage, statement coverage, and I think file coverage. But anyway, this kind of report just gives you sort of a quick look. So even if I wasn't working on notification.js, I might want to take a look and see if there's any interesting test cases that aren't being covered in that file. And if so, I'd either fix them or maybe add something to the sprint backlog to be taken care of later. And this is what it looks like in Jenkins. So this is a report that you get with the Kobatura code coverage plugin, and other plugins provide similar reports. So you just get kind of a nice trend that shows how your code coverage is over time. The one that we pay attention to is the line coverage, and we like to have above 90%, and so that one's been above 90% for the entire time that we've been keeping track. Okay, so the next practice, you want to run comprehensive end-to-end or functional tests in your pipeline, depending on whether it's UI or back-end kind of stuff. So some of the reasons it's important. So obviously, integration type tests are going to catch problems that your unit tests don't. So, I think most people probably understand that. I'm going to talk about this in another slide, but sometimes thinking about end-to-end tests early helps you catch poorly written specs. And for me, this is kind of the main thing that enables us to do CI/CD the way we do it, where each pull request gets merged into master and deployed immediately. To the extent that I feel comfortable that we have good tests, I feel comfortable that we're not going to break anything when we merge changes. Okay, so some of the ways that we put this into practice. One of the things I like to do is early on every project, I have somebody write the first test very early in the project. The reason this is important is because these kinds of tests often need a lot of infrastructure or scaffolding, and sometimes they're difficult to write. So if you can get somebody that's a little more senior on the project to write a test, then other people have a pattern that they can follow. And then so they're more likely to include these types of tests in their pull requests. It's important to be able to run the tests locally. I think early in the project, we sometimes had some repos where there's really no easy command to run the tests, and so they might fail in Jenkins, but then they're hard to debug on your local dev box. So we've kind of eliminated that, and so we make it a requirement that there's always one command that you can run that just runs all of the end-to-end functional tests. And also, as I alluded to, if we get a story from a product owner that we feel like we can't write a test for, we will send it back and say we need better requirements. So let's take a look at that. So here's a contrived story, but something you might get. So as an admin, I should be able to add a user to a group so that they can log in. Probably have a little bit more detail, but I think you get the gist. So if I look at that, I could think of a possible end-to-end test, assuming that all of this stuff was available. So open the user management UI, and then add the test user, and then find the validation. I log into the user and verify the expected home page is shown. So in this case, the story seems okay. I can visualize writing an end-to-end test, so we don't have to send the story back. Okay, next thing, you want your CI/CD test environment to match production as closely as possible. So let's look at why this is important. So it's actually possible to have things passed in Jenkins that have problems in production. And since we're a Node.js shop, I pointed out one of the things that we've seen in the past. We don't see it anymore, but it's possible to have a different version of Node.js running your test in Jenkins than you have in production. And so it could lead to these sorts of problems. Also, I feel like it helps devs better prepare for their on-call shifts, because if there's a problem in the CI/CD pipeline, it requires a lot of the same skill set as diagnosing problems in production if the environments are very close. Incidentally, this is one of the reasons that Kubernetes and Docker are really popular right now. Docker lets you build an image, and then you use it in your pipeline, and then run tests against it, and then deploy that exact same image to production, and Kubernetes makes it easy to deploy it to different environments. So in practice, this typical pipeline might look like build a Docker image, deploy it to some cloud environment, run tests against the deployment. If there's no failures, then we start trying to deploy to production. The first thing we do is deploy to a canary pod, let that take a small amount of production traffic, and if there aren't any errors, then we replace all of the production pods with the new image. And this is all done as part of the Jenkins pipeline. And this is kind of what it looks like a little bit in the Jenkins UI. So the top job is kind of the main job, and then the deploy job is a separate job that gets kicked off if everything looks good in the main job. So you can see we deploy to dev, then to test, then to prod. And in each of those, we use a canary pod first to make sure that there aren't any problems. Okay, the next thing, one of the things that we did that really improved our pipelines was using a lot of mocks and faking service dependencies. So let's talk about why this is important. So mocks can increase the predictability of the test, particularly if you have dependencies that either are flaky or have a lower SLA than you or have outages or something. Those things could all affect your CI/CD pipeline. So if you use a mock, then you don't have those sorts of problems because the mock always does what you program it to do. And as kind of an added bonus, mocks are usually faster than real services. I made a note that if you do this, you're making an intentional trade-off that you want your CI/CD pipelines to stay healthy, but in doing that, you're taking on a little bit of risk that your real services might have problems talking to your dependencies. So there's some ideas about how to handle this. You might have a separate Jenkins job that runs periodically, or you might do manual testing, or you could do a blend, which we do on some of our projects. So we have a large number of tests and that run against the mock, and then we have just a few that run against the real dependencies to make sure that nothing's changed and that everything still works the way we expected. And what it looks like in practice, since we're a Node.js shop, we use a Node module called knock to mock dependencies. And so this is just a little code snippet that shows what it looks like to mock the response of a REST API in one of our tests. In other cases, we use dependency injection if there's not a good out-of-the-box solution. So in this case, we're able to run our application using either the real store or a fake store that we wrote that looks just like the real store. And we use this when we're running our end-to-end tests because we feel like our end-to-end tests are validating that the application does what it's supposed to rather than the store does what it's supposed to. Okay, and here's a topic that's near and dear to my heart. You should monitor your CI/CD pipelines. So let's talk about why this is important. So as I've shown, problems can creep into even healthy pipelines. And if the pipelines are slow or flaky, it slows things down. And you probably want to catch these problems as early as possible. So here's how we do it in practice. I've already talked about some of our monitoring solutions. Another thing that we do, we take the output of the monitoring plugin at the end of every sprint. We have a retrospective, and we specifically look at the build times and success rates for our jobs and determine if maybe we need to allocate some time in the next sprint to improving them. Okay, you need to have a plan in place to address CI/CD problems. Bottom line is it costs money. If this is your only way to get fixes and changes into production, it's a bad thing. And just a reminder that external dependencies can cause problems for your CI/CD pipeline, so it's not even necessarily something that you've caused. So here's how we do it in practice. We have monitoring so we know when problems occur in the first place. We address high priority issues immediately, so if something's just broken and we can't get work done, then somebody's going to fix that right away. Otherwise, lower priority issues become part of an infrastructure Scrum backlog to be dealt with later. And it's handled differently by different teams. Some teams require their on-call engineer to work on the infrastructure backlog during their on-call week. My team actually feels like we have a small enough number of these tasks that we just pull a couple into every sprint, and that gives us a pretty good balance. All right, if you're using CI/CD to deploy every pull request, then you need to have a plan in place to address bad deployments. So obviously, even in the best of worlds, problems can occur, and you should have a plan in place before they do, and you should have the plan documented so that when you're under the gun, you don't have to figure out what to do. So here's how we handle it. So we have, again, monitoring so that we know when there's a problem. We maintain an on-call Slack channel. So sometimes our partners will let us know if there's a problem, but a lot of time it's just us getting alerts and looking at our health metrics. Another thing we do is we ask our engineers to monitor our dashboards and health checks if they're merging something that seems like it's risky. And we have our procedures for backing out changes documented, and we even sometimes practice doing that at our offsites. And the final thing, if in the event we did have to back something out, we always write up a postmortem and identify any process improvements that we can make. And when we're doing this, it's important that the focus is on the process, not on the engineer, because we want people to be honest. And so it's just about how can we be better as a team, not how did one person mess up. Okay, finally, I suggest if you're using Jenkins, you should use declarative pipeline. So some reasons it's important. It actually forces you to put a lot of thought into how your job's structured. With scripted pipeline, it's a little bit more freeform, and so it's easier to make a mess. It discourages you from using scripts. You could still use scripts, but the end goal is to have simpler pipelines, because the fewer moving parts, the more likely things are going to succeed. And finally, if I'm reading the tea leaves correctly, declarative pipelines where Jenkins community is putting the most effort. And so if you're using declarative, you're probably going to benefit the most from those changes. And so here's one concrete example. Blue Ocean actually has a pipeline editor that lets you change your jobs in the GUI, and it only works with declarative pipeline. So real quick, it's just what a declarative pipeline looks, one of our jobs. I'm not going to spend a lot of time on this slide because we're running out of time. And so quick conclusion. So I want to do a postmortem about my monitoring, because this is part of our culture at GoDaddy. And so here's some things that went well. So we were able to make the improvements to the plugin and start gathering stats quickly. We were able to address our biggest biggest issue quickly. And we had the data that we needed to be able to balance CI/CD infrastructure with feature work. Things that could have gone better. I feel like maybe I wish I'd thought of targeting test case monitoring from the start, because we still have problems with flaky UI tests, and that's something that I've seen throughout my career, so something that would have been good to think about earlier. I feel like I could have done a better job evangelizing the value of the monitoring plugin. Kind of not a surprise, I'm an engineer. I like building things more than I like talking about building things, but it was kind of driven home. Last week I was giving a preview of this presentation, and somebody on my team came up to me and said, gee, I didn't know that we had all those charts available. So clearly I could communicate better. So action items. I'm going to add support for monitoring test case health and code coverage. I'm going to try to give some more internal tech talks. Maybe I'll try to give this talk at the Seattle area Jenkins meetup if there's interest in it. And okay, here's a few items that I hope you can take away from this presentation. So I hope I've convinced you that monitoring build health is something that's worth doing. I think it's important to find a way to look at build metrics in regular intervals, whatever that means to you. Again, we integrate it into our Scrum cadence, but you may have your different way. So here's an example of some things you can measure. Build time, build success rate, stage errors, coming soon, test information. And one of the things that's nice about having these types of metrics is that when you're making changes to your Jenkins file, you can actually look at it as kind of an A/B test. And instead of just blindly putting it in and saying things are better, you could actually look at the data both before and after and prove that it was better. So it's a good idea to document and discuss your own CI/CD practices to help keep your team on the same page and make sure that they're still working for you. It's something that we do relatively often on my team. All right, well, thanks for attending the session. I hope you found something useful. This is my email address. If you see me walking around Jenkins World, I love to talk to people. And are there any questions?
I just have one.
Yeah.
Your plugin, you were showing it as GitHub.
Yeah.
Only GitHub, or is it Git?
It's called, so the plugin ID is GitHub Auto Status plugin, because that's what it did originally. And so that's the plugin ID. I've rebranded it, so if you go to the wiki, it says job and stage monitoring plugin because it doesn't just do GitHub. I'm trying to figure out the best way to kind of make that transition.
I just figured, the point was, it's just a URL to wherever your repository is, right?
Yeah,
It's just doing get pull, right? So,
yeah. All right, yeah.
For the statistics plugin that sends the information to Influx,
Uh-huh.
you use Grafana as the front end.
Yeah.
Have you tested that out at scale? I
Um,
noticed you have only a few jobs in your JSON master.
So no, I haven't tested it out at scale because we don't have a ton of jobs. So I don't really have a good answer for that. I assume that it's built for, it's a time series database, that it's built for scale, but I guess that's maybe one of the reasons that I need to look at other solutions like Elasticsearch. Do you have like information about InfluxDB experience? No, just curious? It's a good question. All right, if there's no more questions, the kind folks at CloudB wanted me to remind you to share feedback, both for this presentation and others. And of course, you have an opportunity to win a Nintendo Switch, which is, I love free stuff, you love free stuff, so please do that. All right, thank you.